3.7 quadratic inequalities. All we want to know is whether when the function is positive and negative. We're only looking for positive and negative. We're not comparing it to anything else. I want to know when the quadratic has a positive value and a negative value. And we're going to write our answers in interval notation. We're using interval notation. Now, so what I have here is a bunch of examples, right? There's no theory involved. This is just using basic algebra skills to determine where the function is positive and where the function is negative. Now, if you want background information, I'm not going to provide a whole lot of background information here. I'm only going through the basic technique, okay? So the first step you're going to do is factor these things, all right? So we're gonna basically, we are looking at x squared minus 6x, the function itself, and we're going to factor it. So this is an example of factoring by finding the GCF. There's a common factor of x here, so I'm going to take an x out. So when I take an x out of x squared, it leaves an x, right? I'm basically subtracting 1 from the exponent. Remember, if you don't see an exponent, the exponent is an invisible 1. So I did 2 minus 1 makes 1, all right? And now, we're taking an x out of negative 6x, and that's going to leave me a negative 6. All right, now what we're going to do is we're basically comparing this to 0, right? So what is the number between positive numbers and negative numbers? It's the number 0. So we find out where this turns into 0, then we would find where it's positive or negative. All right, so we're going to set each factor equal to 0. X is a factor, we set equal to 0. And x minus 6 is a factor, we set equal to 0. So this equation is already solved for x. It's right, x equals 0. This one I have to continue solving. So I'm going to add 6 to both sides, and I get x equals 6. Now, what we're going to do is draw a number line. 0 and 6. And what we're going to do is just plug in numbers, right? So remember, this is a number line. These are the values where that function turned to 0, and then in between them, or these other parts, it's going to tell us whether it's positive or negative. All right, so pick a number left of 0, right? Pick a number left of 0 is negative 1. So plug negative 1 into here. That'll be negative 1. Actually, I want to do this part right here, okay? Plug negative 1 in there, it'll be negative 1 times negative 1 minus 6. That's going to be negative 1 times negative 7, which is positive 7. Now, the fact that the 7 is not important. What's important is whether it's positive or negative, okay? It's positive, so we'll put positive here, okay? Now we plug in a number between 0 and the 6, say 2. So plug in 2, that's going to be 2 times 2 minus 6. 2 minus 6 is negative 4. 2 times negative 4 is negative 8. So it's negative. So I only want the sign of the, okay? I only want the sign. Now we plug in a number to the right of 6. So say 7, so it's 7 times 7 minus 6, right? I'm plugging it in here, 7. Replace each x with 7, all right? So 7 times 1, which is positive 7. So it's positive. So these numbers here, negative 1, 2, and 7, are representative numbers of each region. That one number represents the entire region, okay? All right, now, so we've got positive, negative, positive, so that means it's positive in this region, and negative in that region. Okay, we're going to write it like this: positive. So it's positive from negative infinity to 0, union, and from 6 to infinity. Now, some people get confused about this negative infinity, positive infinity. This is the x values that give me a positive value. I'm not saying these are all positive numbers. In fact, none of these are positive numbers. What I'm saying is these negative numbers, when I plug them in, gives me a positive value. Okay, so this is the interval. It is the interval notation for this number line. So remember, on the left-hand side is negative infinity. On the right-hand side is positive infinity. Don't look at these signs to determine what that infinity is. When I'm going to the left, it's negative infinity. When I'm going to the right, it's positive infinity. So that sign of the infinity means I'm going to negative 1, negative 2, negative 3, negative 4, and so on until negative infinity. That's what that negative sign represents. It has nothing to do with this positive sign. Okay? So it's positive in this region. And this region is described by negative infinity to 0. It's positive in this part. And this region is described as positive 6 to positive infinity. Okay? All right. Now, where is it negative? It's negative in between these two numbers. So it's between 0 and 6. All right. And that's the answer to part A. This is the answer we're looking for. All this other stuff is work. If you don't need to show every little step of that, right? The most important step is this factor step here and the number line. All this other stuff, if you can do it in your head, or if you see a pattern, and you're welcome to use that pattern. There's definitely a pattern to these, okay? All right, let's look at example B. Okay, so this is a regular factoring problem. What are the factors of positive 40 that combine to make negative 13? That'll be negative 8 times negative 5. If you need help with factoring, please ask, okay? But this is not a lesson about factoring. So it's going to be x minus 8 and x minus 5. We send that equal to 0. So set each factor equal to 0 and solve each one separately. By the way, if you skip any of these steps, that is perfectly fine. You don't need to show every little step on these problems, okay? But make sure you get the signs correct. In the most recent test, everybody was able, most people was able to factor this, but gave me the wrong answer here. Notice this minus 8 turned into a positive 8. This minus 5 turned into a positive 5 in terms of the answer. Okay. Some people are not making that connection. So this is a number line for the x-axis. So 5 is on the left and 8 is on the right. Now plug in some numbers. So I'm going to plug in a number left of 5. 0 is a nice number, right? So that's going to be, if I plug 0 into 0 minus 8, that's going to be negative 8. 0 minus 5 is negative 5. And negative 8 times negative 5 is positive 40. So that's positive. Pick a number between 5 and 8, say 6. That's going to be 6 minus 8, which is negative 2, and 6 minus 5, which is 1. Negative 2 times 1 is negative 2, so that's negative in there. And pick a number bigger than 8, so say 10. So it'll be 10 minus 8 is 2. 10 minus 5 is 5. 2 times 5 is 10. It's positive. Here we go. So when is this positive? When is this quadratic positive? Quadratic is positive when it's negative infinity to 5 and then 8 to infinity. And it's negative from 5 to 8. And this is the answer to question B, or example B. All right, continuing, let's look at example C. So this is a difference of two squares. You're supposed to recognize this, okay? But if you still don't have it memorized, there's another way to look at it. Right, if you recognize this, you could just say, oh, that's just x minus 4, x plus 4. It is a difference of two squares. If you don't recognize it, you still can use it the crossway. A lot of you are really good at the crossway. So you do negative 16. What's the middle term? There's no x term, right? There's no term where there's an x with no exponent, or the exponent of 1. It's 0. So what are the factors of negative 16 that combine to make 0? Well, negative 4 and positive 4. Negative 4 times 4 is negative 16. Negative 4 plus 4 is 0. Hence, here it is. Negative 4, positive 4. Set each factor equal to 0. Add 4, add 4. X equals 4. Subtract 4, subtract 4. X equals negative 4. All right. Now, so we make our number line. We want the negative 4 on the left, positive 4 on the right. Pick a number left of negative 4, and that will be negative 5. So here, plug it in here. So that'll be negative 9 times negative 5 plus 4 is negative 1. That's going to be positive 9, so it's positive. Plug in the number between negative 4 and 4, I like 0. So 0 minus 4 is negative 4. 0 plus 4 is positive 4, so that's negative 16. So that's negative. Plug in a number bigger than 4, say 5. So 5 minus 4 is 1. 5 plus 4 is 9. That's positive 9, so that's positive. Have you seen the pattern yet? Notice each time was positive, negative, positive, positive, negative, positive, positive, negative, positive. That streak is about the end. All right. Let's see here. So we're going to make our answer. It's positive from negative infinity to negative 4. And 4 to infinity. And it's negative from negative 4 to positive 4. All right. Let's go on to D. Okay. So whenever you see a front number is negative, you're going to take a negative out. So that's going to be 5x squared minus 27x minus 18. So now we're going to use the Lizzie method. 5 times negative 18 is negative 90, and we need to make negative 27. To get that, it's negative 30 and positive 3. All right, so that's going to be the negative on the outside, negative 30. So it's negative 30 divided by the leading coefficient of 5. This is the Lizzie method. And x plus 3 over 5. Okay, so that is x minus 6. And according to Lizzie method, we bring that 5 forward. So it's 5x plus 3. Set each factor equal to 0. Solve each one. All right, so we'll make a number line. It's negative 3/5 here and 6 there. All right, negative 3/5 and 6. Pick a number left of negative 3/5, and let's see, that would be, say, negative 5. Let's plug in negative 5. So I'm using this version. Negative 5, so it's negative of negative 5 minus 6 is negative 11, and negative 5 times 5 is negative 25, plus 3 is negative 22, I think. Yeah. All right. And I have 3 negative signs, right? 3 negative signs make a negative. You don't have to work it all out. You don't have to figure out what 11 times 22 is. 11 times 22 is like 242. Okay? Don't quote me on that. I'm not sure. All right. But I know it's going to be negative because negative times negative is positive, and then positive times negative is negative. So it's three negatives together make a negative. Here, plug in the 0. If I plug in the 0, so I have that negative on the outside. 0 minus 6 is negative 6. And 5 times 0 is 0. Plus 3 is 3. So I got 2 negatives. Negative times negative is positive. Positive is 18. So it's positive. And if you see a pattern, right, it went positive, negative, positive in example A. Positive, negative, positive in example B. Positive, negative, positive example C. This one is starting negative, and the second one's positive. What do you think the next one is going to be? If you guess negative, you're correct, right? So they're always going to alternate. When there's 2 slots like this, right, or 3 regions, it's always going to alternate. For these quadratics, if there's 3 regions, they're always going to alternate. All right, I want you to notice something else. This had a leading coefficient that was positive, so it started with positive. Leading coefficient is the x squared term. If the x squared term is positive, it starts positive. X squared term is positive, it starts positive. X squared term is negative, it starts negative. So it's negative, positive, negative. In fact, I am so positive of this. Well, I'll just confirm. All right, let's plug in a number bigger than 6. We'll plug in 7, so it's negative of 7 minus 6 is 1. I'm plugging it in here. 7 minus 6 is 1. And then 7 times 5 is 35, plus 3 is 38. Okay, these are both positive. 1 and 3 are positive, so there's only one negative sign, so the answer is negative. It's going to be negative 38. Okay, so it's positive only in the middle this time, so it's negative 3/5 to 6. And it's negative on the ends, so it's negative infinity to negative 3/5 and 6 to infinity. So those are our intervals. All right, example E. Here, there's a common factor. So I'm going to take out a common factor, so it's negative 4x is my common factor. Okay, so you might think, well, negative is not a common factor, right? Only one of them is negative. Generally speaking, when the leading coefficient is negative, I always take a negative out. Right? I don't care if all of them are negative or not. If the front number is negative, I take a negative out. And there's obviously an x in common. All right, take it out. So when you take a negative 4x out of 4x, negative 4x squared leaves an x. Positive 48 divided by negative 4 is negative 12. And the x is gone. All right, this is not a trinomial, so it's not that x thing, right? It's not this thing. All right, and you set each factor equal to 0. Solve for x. So I got x equals 0. Add 12, add 12. I got x equals 12. 0, and 12. To the left of 0, so here, if you said, oh, it starts with a negative, so it's going to be negative, positive, negative, you're absolutely correct. If you want to verify this, so pick a number left of 0, right? So say negative 1. So it's going to be negative 4 times negative 1 is positive 4. And then negative 1 minus 12 is negative 13. So that gives me negative 52. So it's negative. Plug in a number between 0 and 12, say 1. Plug in 1. So it's going to be negative 4, right? 4 times negative 4 times 1 is negative 4. Then 1 minus 12 is negative 11. So that's positive 44. So it's positive. Plug in a number bigger than 12, say 14. Let's go closer than that. 13. So 13, negative 4 times 13 is negative 52, I think. And then 13 minus 12 is 1. So it's negative 52. So it's negative. Okay. If I'm not quite right on the 52, I'm very close to it. Okay. All right. So what are the answers? So it's positive between 0 and 12. It's negative from negative infinity to 0 and 12 to infinity. There's my answer. Okay, last example. Example F. Okay, so here we got negative x squared minus. Okay, so whenever there's a negative up front, I'm going to take a negative out. So it's x squared minus 8x plus 16. Then what are the factors of 16 that combine to make negative 8? So it's negative 4 and negative 4. So that means I got negative x minus. I got this. It's the opposite of x minus 4 times x minus 4. You only have to solve this once. You don't have to show me. Well, you can if you want to. But basically, I only have one number on this. So the pattern doesn't work when there's only one of these. Okay, the pattern does not work when there's only one of these. So plug in a number to the left of that. So say 0. If I do 0 minus 4, so what I have is this negative sign on the outside, and I'm doing 0 minus 4 and 0 minus 4. This is negative times negative 4 times negative 4. So I got 3 negatives. That's going to make it a negative. If I plug in 5, right, number bigger than that. So I'm going back to this one, negative. There's a negative on the outside, and I'm doing 5 minus 4 and 5 minus 4. So that's 1 and 1. Negative 1 times 1 is negative 1, so it's negative. So it's negative on both sides, okay? So when there's only one of these, right, up here where there were two of these boundaries, all the rest of these had 2 boundaries, okay? So this one has 1 boundary. If it's 1 boundary, it's going to end up being the same sign on both sides, okay? Sometimes there's no boundaries, then it's just the same sign all the time. So here, so if this were a positive, then this side would be positive, okay? So how do I answer this question? You say positive, you don't have to give an answer to the positive. There's nowhere it's positive. Okay? So when is it negative? So I'm only looking at this, right? So negative is negative infinity to 4 and 4 to infinity. All right? And that's it. Whew. Have a good night.